Good morning. Thanks for coming over. My name is Jose Barreto. I am a program manager with the file server team at Microsoft. And in the Windows Server 2012 release, we have been working on a few interesting things. One of them is SMB 3.0. So if any of you saw previously that this talk was called Hyper-V over SMB 2, and we now changed it just to Hyper-V over SMB because we're now calling it SMB 3.0, right, the new version, right? So clear some confusion there. What we are going to do today is focus on a specific scenario that I have been working with the Hyper-V team, which is how to use file storage with Hyper-V, okay? Now, the talk is not about Hyper-V per se. What we're talking about today is how to use Hyper-V with file storage. So if you want an overview of storage for Hyper-V or a Hyper-V focused talk, that's not it. However, we're going to explain how the file server got updated to be used as storage for virtualization. That's the main focus. We're going to take a look at what happened, what changed in SMB. We're going to show you a little bit of how to do it. I have a demo on that. And we will talk also about some configuration options, because there are quite a few different ways you can go about doing this, and we're going to comment on some of those. And then we're going to wrap up with a series of sample configurations that you can experiment with and trying to come from a more simple setup all the way up to a very complete set of capabilities, fully redundant and all that. So let's get started. So if you've been playing with Windows Server 2012, you probably have noticed that there is a lot new in this release. In fact, we're having a hard time trying to explain to people everything that's in there because it is a long list, okay? What we're doing here is mostly, this is the slide that people usually start their talks with. There are different areas. We fall somewhere in between the first two sets of capabilities. Mostly beyond virtualization is where we would sit. But more specifically, what we're trying to do here is do file store for virtualization. So how many of you went to Jeff Woolsey's talk yesterday about the Hyper-V features overall? Awesome. Yeah. So that was a great talk. I was there as well. And just looking at all the things we did in Hyper-V, this is one piece of it, right? We're not talking about other things that are related, like storage, live migration, replica, you know, the support for all the other capabilities that just came about. This is specifically about file storage. And today, you know what capabilities we have in terms of storage for Windows Server 2008 R2. You can use directly attached storage, you can use iSCSI storage, you can use fiber channel storage, and that's it. We are actually introducing in this release an entirely new way of doing it, which is to use an SMB file share to store your VHDs. And to be clear, this is not for the library, this is for the actual running VHDs, okay? And configuration files and snapshots. Pretty much the whole thing. You can run your entire set of workloads from a file share. And the main reason why you would do this, some people start with the notion of saying, oh, we're going to provide you less expensive storage. I usually start by saying it's a more flexible solution. So today, for instance, when you're trying to do any kind of shared storage, in this case it would be a iSCSI or a fiber channel, and you're doing clustering, you can only expose a set of LUNs to a cluster at a time. With file storage, you can actually have a few shares that are equally exposed to multiple clusters, or to a cluster and also some standalone systems. And that's a fine way to do it. You can do migration of all kinds in and out of file storage. And have you seen the shared nothing live migration demo? What you might not see is that the way shared nothing live migration works is that Hyper-V inside of it has a little trick to go create a temporary share, do migration, and then remove that share. So the trick is actually related to having an SMB, because in the end, every Windows machine is a potential SMB server and SMB client, even Windows 8 client, right? So it's about flexibility. It's about making it easy to provision. We'll talk more about this. It's about also leveraging your converged network. Today, we have much more capable network infrastructure. We have 10 gigabit Ethernet. We have multiple 1 gig Ethernet. We have very sophisticated RDMA NICs that can go all the way up to 54 gigabits per second on a single port. So if you're doing all this, you can actually leverage those for file storage. You've been doing some of this with iSCSI. You can do now with SMB as well. And there's cost. We do have some configurations where you're using file storage that are expected to cost less. Less to acquire, also less to manage. Because I would bet that most of you already know how to create a file share in Windows, right? Or how to monitor that file share. And we'll teach you a new set of tricks as well. Now, the reason why we are just now supporting file storage is because what we had before had some limitations. So the new 3.0 version of the file protocol actually introduces a new set of capabilities that were specifically designed for application storage. So when we were talking about SMB 3.0, the capabilities that we put in there are not a random set of capabilities. Those were specifically targeted at making sure that you can have file storage that is just as good as block storage, okay? And that's not an easy thing to say. So for instance, we introduced the notion of transparent failover. So in Windows Server 2008 R2 and SMB 2.x, if you had a cluster, you could fail over between cluster nodes, but that was a disruptive operation for the client. We changed that. And in Windows Server 2008 R2, if you have multiple nodes in a cluster, a file share would be active in only one node at a time. We changed that. In the previous release, if you're using regular Ethernet networking, we would use a fair amount of CPU to do small IOs at high speeds. We changed that. If you had multiple network paths, SMB will only use one. There was no equivalent of multipath I/O. We changed that too. SMB 3 introduces also the capability to do encryption, meaning that you can simply set one property on a share and all the traffic in and out of that share is encrypted. That's new in this release. And we also introduced a new way to do VSS backups using file shares. So that is also new in this release. And last but not least, we're doing PowerShell for SMB. But, I mean, everyone is doing PowerShell now, so we're just trying to keep up on that. Let's start by talking about transparent failover. So the concept is fairly simple. If you have a cluster and you have multiple nodes, you are talking to one of the nodes in the cluster. Now, if that node fails, in previous releases, we would bring that share on another node, but whoever was talking to that node would get disrupted. That's okay if you're just saving a Word document, because you can always press save again and write to the new node, right? But that's absolutely not okay if you're doing Hyper-V, because Hyper-V never lets go of that file. And if you simply break that connection, if you require something there, you're going to start not having your VM working anymore. And that's definitely not acceptable. So what we did in this release was, instead of asking Hyper-V and SQL and IIS and everyone that can potentially store data in a file share to change their code, we changed our code. So now the SMB protocol itself, the client and the server, when you lose a connection and the server moves to another node, we actually will move state to that node, and the client will transparent connect to the new node. Does that make sense? So if you had an open file on one node, you had an open file when you move to the other node. If you had locks, the locks will be there when you get to the other side. In fact, Hyper-V will be unable to tell that something happened. What Hyper-V might see is just that there was some operation that took a little longer to complete. That's it, a few seconds longer. And we make sure it's never more than 25 seconds, even if you have a few tens of thousands of handles, a few tens of thousands of files open there. In fact, the idea is if you have about 10,000 VMs running off a file share, of a file node, and you fail that from one node to another node, it should recover on the other side in time so that the Hyper-V nodes can just say, oh, that took a while to write that data, but that's okay. Okay? That's the concept of transparent failover. Of course, you can only do that if you're running a failover cluster. That's a given. So you need multiple file servers, okay? And for that to work, both your file client and your file server have to be running SMB 3.0, okay? And you have to make the share mark as continuously available, but that's the default now. Scale out. So in the past, if you have a file server with 2 nodes, one node will be serving the clients, the other node would be passively waiting for something to happen. You could make what we call a dual active, but you had to have one share on one node, another share on another node, and then you have to kind of know that one share is here, one's there, and you had to manage that yourself. In this release, in Windows Server 2012 with SMB 3.0, you can create a single volume behind the cluster. You can create a single share on that volume, and all cluster nodes will give you access to that same share. Does that make sense? Now, I want to say a single client will never connect to more than one node. But if you have 100 Hyper-V servers talking to a cluster of 2 file servers, because we do round robin when we connect, it is likely that half of the Hyper-V nodes will be talking to one file server cluster node, the other half on the other one. Okay? And of course, if you do maintenance on one, you can move all live through transparent failover to the other node. You can do maintenance on one node, and then you can move them back. And if you want, you can write a simple script to automatically rebalance your connections between the 2 nodes, right? Have you heard of cluster-aware updating? Look that up. That's useful. It's one of those things that you probably should keep up on the Windows Server 2012. Sorry about that. There's too much going on. There are a number of capabilities here. And I have just one thing that I wanted to mention about this is most of the work on this is not on the file server team itself, but it's a combination of the file server team and the cluster team. Remember when in Windows Server 2012, when you create a cluster share volume, there was a checkbox that you have to say, yes, I agree? Remember what that said? You can only use CSV with Hyper-V. Guess what this is? This is a file share on a CSV volume. That's how we see it on all nodes. So the short story of scale out is put a share on a CSV volume, it shows up on every node. And of course, I don't want to diminish the fact that we have a whole lot of coordination, a new concept called a distributed network name that allows us to actually refer to a single name that refers to the set, and how we connect, and we treat all the interesting cases where someone comes in on one node, then connects to another node, and we have to do all the kind of coordination. Or simply getting a list of sessions for share now requires you to kind of get the list from all the nodes, put it all together, and give you a single list. That's part of what we did here. Lots of goodness on the CSV side. I'll give you just one reminder. If you're doing this, there's something called CSV caching. Have you heard about that? Look it up. Okay? That is important. It relates to performance. And if you're deploying this, you should be doing also caching. Okay? Makes a ton of difference. SMB Direct. That one is a personal favorite of mine because I am the PM for that feature. The idea here, there is an entirely new set of capabilities in NICs these days that used to be a privilege of people that work in high-performance computing. SMB Direct is essentially letting the NICs do the actual transfer of data. And when you need to, for instance, fetch a large amount of data over a file protocol, so say you want to read 512K of disk from another node. Today, what we do is we get that request, we send down to TCP, it goes to the other side, we send small bits of data over the wire so that it gets to the other side reassembles that and gives us back the data we requested. It turns out that you can't transfer 512K over TCP IP on a single packet. Look that up, right? Now, what we do, we now support what we call remote direct memory access. So the way this happens, I'll try to do it quickly. We have another session on this right after here, this one, if you're interested. But what we do is in SMB now, first of all, we detect that both client and server have RDMA-capable interfaces. When we detect that condition, which, by the way, is automatic, you don't have to do anything other than buy the right NICs, we will, instead of saying, give me the data, we will find a place in memory on the client side that says, oh, I want to transfer data, 512K, to this memory address. So I registered that memory address with my NIC, and I send a request with a token representing the memory to the other side. On the other side, the server says, oh, you need this much memory, and you're doing RDMA. So I'm going to tell the NIC on my side to write to the NIC on your side using the token of the memory that you registered. Short story, we transfer the whole 512K, but we don't do it. It doesn't flow through TCP/IP. The two NICs do the transfer for us. There's a few effects of that. First of all, it's fast because the NICs know how fast they can go and they will go at full throttle. The second thing is you will notice that the CPU utilization drops dramatically because we're no longer breaking things down in small packets, making the transfer, then reassembling on the other side. We're simply dropping the data directly where it needs to go. Okay? We have a few partners that are providing solutions for this. We have different types of NICs that have this capability. And if you're interested, come to the next talk on cluster in a box, RDMA, and more. I believe it's the next time slot at 12. I'll be speaking there as well. Okay? Very cool stuff. I'll give you two data points. We have at the Mellanox booth here a demonstration showing a single VM doing 80 gigabits a second I/O. Just let that sink in. So 10 gigabytes a second from a VM to a file server. Okay, so this is good performance. Oh, and CPU utilization while doing that, less than 5%. Okay, so very, very good capability. We have another partner that's doing 15 gigabytes a second. That's 120 gigabits a second, also using this capability. Now, speed is nothing if you can't have fault tolerance, right? That's the other thing that we heard loud and clear, that folks want to do file storage, but they don't want that a single cable pool can destroy your entire solution. So what you want is fault tolerance. So in block land, we have multipath I/O. In SMB land, we have SMB multi-channel. SMB multi-channel, technically, is just the ability that if you have a session between your client and your server, you can have multiple TCP connections at the same time. So there are many reasons to do that. One of them is simply you have a very fast NIC, like a 10 gigabit NIC, and when you use a single TCP connection, because of the way our stack is organized, you are actually using a single core of your CPU to do that. I'm not sure if you noticed, but the cores are not getting faster. We're just getting more cores. And if you have anything that only uses one core, that's never a good idea. So what we did in SMB is automatically, when we detect that we have a NIC that has the capability called receive side scaling, which is I can use multiple TCP connections and spread across cores, we will automatically create additional connections. So if you have a single 10 gig NIC that is RSS capable and SMB detects that, it will create additional connections so that we can spread the load across different cores. We also use this to do aggregation across NICs and fault tolerance. So if you have two 1 gig NICs, you effectively get 2 gigs of throughput on a single file copy, on a single VHD when you're running Hyper-V. Okay? So if you have two 1 gig on one side, two 1 gig on the other side, and you simply in Explorer drop a file to a folder, SMB will automatically detect that you have that condition and will automatically engage the multiple paths. Now, if right in the middle of the copy, you disconnect one of the 1 gig NICs, nothing happened other than the fact that we go from using 2 gig down to 1 gig. Now, better yet, if it's a long-running copy, if in the middle of the copy you reconnect the second 1 gig NIC, SMB will also detect that, and right in the middle of the copy, you'll see good throughput, drop down to 1 gig, go back up to 2 gig. This is now a capability of SMB, and we have some interesting side effects of that capability. For instance, let's say you're copying a file and you're on a laptop, and you start the copy over wireless, and then you look at it and say, oh, this is slow. So what you do, you dock your laptop, and you now have a 1 gig. SMB will look, say, oh, you have a faster NIC. I'll switch to it. So if you have the capability to get to the same file server through both paths, it will find the best path and will automatically switch. That is part of multi-channel as well. And remember those very fast RDMA NICs? We'll use multiple of them at once. So if you have two 56 gig NICs, you effectively get over 100 gigs of throughput. If you have three 56 gig NICs, then that's how the guys from XIO did the 15 gigabyte a second throughput. That's how the Mellanox guys did the 10 gigabyte a second throughput, using multiple NICs at the same time. Okay? I also have a session tomorrow on SMB multi-channel, especially in how it relates to NIC teaming. So if you want more detail about that, there's a session tomorrow. We're going to talk in detail. SMB encryption. SMB encryption is something we've been hearing from folks. You know that we now can do BitLocker on servers, right? So you can have a BitLocker volume even in a cluster. But that's encryption at rest. There's another concern about data flowing over the wire and your need to encrypt that as well. So we can provide you with encryption on the wire through SMB. So you might be thinking, oh, do I need to do IPsec? Not if you don't want to. If you just want to do SMB encryption for a specific share, if you have 10 shares, one of them you need to do encryption, there's sensitive information there, you can do it, no IPsec required, unless you want to actually do it for the entire traffic between the two boxes. You might be thinking, oh, do I need a PKI infrastructure? Nothing against certificates. Your web servers need those, and other workloads will require certificates, but we already have a session key between a SMB client and SMB server. In fact, we already do signing in SMB 2.x. So what we're doing, we're simply using that session key to do our encryption. Short story for you is set the bit, done. Traffic is encrypted. Now, you might be thinking, what's the penalty for encrypting all the traffic? I'll get you. What's the penalty to encrypt all the traffic? Well, we chose a specific type of encryption that has offloads in the latest CPUs. So if you're using one of these new CPUs that have this kind of offload, most of the encryption is nearly free if you have the right type of CPU. And I'm talking CPUs that you actually want to use, like the Intel Core i5, Core i7. Okay? So nearly free encryption that's easy to configure. You had a question? Will this work for print servers? I don't know. I think that the configuration is for file shares. I'll follow up on that. Okay? Cool. But if you are doing file shares only, it's a very simple thing. We had another question. The question is, how do we exchange the session key for encryption? Is that right? So SMB always had a mechanism where we do these exchanges, and we never share the key on the wire. Right? This actually doesn't require Kerberos, although I highly recommend that you use Kerberos. But SMB had that from the beginning. We have a mechanism by which client and server negotiate security without sharing the key on the wire. We're simply reusing that session key. It's a smaller key than what you get in a private-public key pairs. But if you understand how that works, the private-public key is just a mechanism that you use initially to create a session key, and then you just use the session key. For us in SMB, since we already had a session key, we don't need that. But to answer your question, the key is never exchanged in the wire. Okay? If you want to get more details about that, there was recording a webcast that we did during TechEd North America that just became available, that you can have some more details on how encryption works. And we have blog posts about that as well. Okay? VSS for SMB file share. So the idea here is very simple. Today, when you're doing backups, we use some infrastructure called VSS, Volume Shadow Copy Services. So the way that VSS works is there is an ecosystem by which when you're trying to do a backup of a specific workload, we talk to the application, we talk to the storage subsystem, we talk to the backup application, we coordinate a process by which we can take a backup that is consistent, right? So for instance, if you're doing a Hyper-V backup, you will talk to the Hyper-V engine. There's a writer in Hyper-V, a VSS writer, that coordinates with the VMs to make sure that the VMs are in a consistent state. And then we talk to the storage subsystem that says, okay, take a snapshot right now. And then the backup application can get the snapshot out of the VSS ecosystem. So VSS is a coordination system for backups. The problem that we had with that is that VSS, up to this release, only worked for block storage. So you had to have something that's block storage in order to do a VSS backup. And we wanted to do a file storage. It just so happens that we talked to the VSS team, and we got them to actually include the ability to use a UNC path when doing VSS backups. So in Windows Server 2012, we now have the ability to have a file share participate in a VSS backup with minor changes to the ecosystem. Short story again, you want to do a backup, you have a backup agent, it coordinates with, in this case, Hyper-V, which is doing the actual snapshotting, and we will remote that request to the file server, and the file server will create the snapshot, and what you get as a result is another share where your backup will be available to you. Okay? Not sure if you use VSS backups today. We try to do it in a way that has the minimum impact possible. There's a recent blog post from the PM from this, Klaus, that outlines all the details. We're working with the backup vendor to make sure they understand now that instead of a volume GUID, backslash question mark backslash volume ID, we can now have a regular file share backslash server name backslash share name as a result of a VSS snapshot request. Okay? There's other things. I talk about PowerShell. We actually made changes to the performance counters in SMB, so you now have per share performance counters. And we purposely did a set of performance counters that look exactly like physical disk counters. So if you have guidance, say for Hyper-V, that you want to have your latency below a certain number, so the average seconds per data request is now available for each share. If you want to know IOPS, we have average data requests per second. If you want to do throughput, we have data bytes per second, just like you do with physical storage. Okay? Since we're doing SQL over SMB as well now, SQL Server guides have all these guidance about how performance should be measured for SQL, and we wanted to give them exactly the same shares that they have for physical disks. Again, we want file storage that works in the same way that you used to with block storage, with a few advantages. We also changed the eventing. We have additional events for SMB Server, Client, SMB Direct. And, of course, Server Manager has full support for creating file shares, including a wizard to do shares for file storage, like Hyper-V and SQL. Okay, let's talk a little bit about how to configure that. We wanted to make this as simple as possible, but we don't want to just create a share with no permission and have you start using it. We want to make sure that this is done in a secure fashion. So to use Hyper-V over SMB, there is a requirement. You must grant the right set of permissions. Now, the way you do it, let's go here step by step. You first create a folder, okay? Then you create a share. You can use the wizard in Server Manager, but I highly encourage you to start learning PowerShell. It's not that hard. New SMB share, you give it a name, you give it a path, and then we have this way to actually pass the accounts that need full access. So you should grant access to the Hyper-V administrator, to the computer account of the Hyper-V hosts, because Hyper-V runs the VMs as special processes that run with privileges. So when you go out of that box, it comes out as the computer account for that machine. So the access has to be granted to the actual machine that you are using, okay, that runs Hyper-V. If you're using a cluster, so all the nodes in that cluster must have access to that share, okay? And you should also include the cluster account itself. So it's commonly referred to as a CNO. So you want, it's the name of the cluster. So you want to give access to that account as well. This is especially important for migration scenarios. Okay? But once you do that, you're almost set. The only thing you want to do is you want to give the same set of permissions to the NTFS folder. So in the beta release, I have a long set of guidance on how to use iCackles to set permissions on NTFS folders. And because NTFS permissions are slightly more complicated because you have inheritance, you have, special bits for things, folks were coming back to me and say, really, isn't there a simpler way that I can do this? Because I can never memorize those iCackle command lines. So what we did, when you create a share now, we have a property of the share called preset path echo. This is new in the release candidate. I highly encourage you to do it. So when you're first creating the share, after you set the permissions on the share, in the share itself, we create a set of echoes for NTFS that match the share permissions. All you have to do is get that and pass over to set echo, and you're done. Okay? So if you know a little PowerShell, you get the SMB share, pass the name of the share, and then you say preset path echo, and then you pipe to set echo. If you prefer to do the share management, the NTFS permission management yourself, that's all fine and good. Okay, you can do that. Most people would like a simpler way, so we offer that. Now, how do you use Hyper-V over SMB? It's actually very straightforward. Whenever you are using before drive letter, colon, backslash something, you use the UNC path. Backslash, backslash, server name, backslash, share name, and so on. Okay? You can use this for all things Hyper-V. So it can be the path for the actual folder for the VM. It can be the VHD. It can be the snapshot. You can do everything over an SMB file share. So here's the new, you're familiar with the PowerShell for Hyper-V now? So we have new VHD and new VM. So new VHD, you pass the path. The type could be dynamic, fixed, and then the size. For the VM, we're passing the name, the path for the configuration, the VHD path, and the memory. You have obviously more parameters. I'm doing kind of a simple one there. Okay? Now, important notes. I get these questions a lot, so instead of trying to answer one by one, here's the frequently asked questions about Hyper-V over SMB. First of all, yes, it's only with SMB 3.0. Okay? Why is that? We worked with the Hyper-V team. They said, you know, I don't want to do this without transparent failover. I don't want to get a call from folks every time a cluster fails over and things stop working. So if you want to deploy this and you want continuous availability, if you have a cluster, you expect it to just work. So SMB 3.0 is required. Multi-channel also was a huge thing on that. We didn't want to get a call every time someone tripped on a network cable. So dual path every time, cluster, highly recommended. Can you do standalone? Yes, you can. We don't recommend because if you have one, you really could have that as a single point of failure. File server dies, you don't have your VMs running anymore. So highly recommended cluster configurations. Okay? Will other vendors implement SMB 3.0? Absolutely. We're working with a whole set of folks. We talked to them since last September in the Storage Developers Conference, and they were up on stage, both the two main ones that went up on stage with us in September 2011. We were there, and both EMC and NetApp said, we will support you day one with SMB 3.0. Okay? So I highly encourage you to talk to them. Make sure they said, are you on schedule? Are we getting that? When is it coming? Right? But they are absolutely providing a solution because file storage is something that everyone is interested in doing. Okay? And since it's a requirement, it has to be 3.0. Another question that's not here is, will you backport SMB 3.0 to previous versions of Windows? No, we'll negotiate down to this version they support, but porting all those changes back would be extremely hard, especially when you think about changes that were done in CSV, changes that were done in networking to support RDMA and RSS and NIC teaming and all those things. So if you pull SMB 3.0, the whole system will come with it. So it's very hard to backport just one feature, right? So SMB 3.0 is Windows Server 2012 and Windows 8 and partner solutions that support it. Okay? As I mentioned, continuously available shares, which of course requires a cluster, highly recommended. Active Directory is required. Okay? Why is it required? Because when we're talking between machines, we need a mechanism to grant permissions to a computer account. If you don't have a domain, do you have computer accounts? Actually, you don't. Right? I have some folks that come to me asking strange questions like, does it work if I grant access to everyone? I say, I'm not even going to talk about that. Okay? If you're talking about creating shares with no security, granting access to everyone, I'm just going to stop talking, right? So Active Directory, absolutely required. Can you make it work in other ways? I don't know. Don't go there. Don't try that, okay? Stop with that stuff. Okay, never mind. Loopback configurations are not required. Strangely enough, there's some folks that want to actually have a file server and a Hyper-V box that are the same box, and they want to actually have the permissions set so that I can access it myself. So if your Hyper-V machine is the same as your file server, then your drives are local. Don't use a UNC path. Use the local path to the storage, okay? There are actual permission implications because when you're not going out of the box to do your permissioning, then it doesn't work the same way. So loopback, meaning Hyper-V box that is the same as the file server box, don't use the UNC path. Use the local path, okay? This also means that if you have a cluster providing file servers and Hyper-V at the same time, right? That means that that storage is also available in that cluster. So again, if the Hyper-V instance is running the same place where the file server is, that's a loopback scenario. So if you have clusters, you need to either use CSV and then all the nodes can see that storage, and you use C:cluster storage as your path, not a UNC path, or you create two separate clusters, a cluster for file servers, a cluster for Hyper-V, or multiple clusters for Hyper-V. Okay? I'm going to elaborate on that a little bit in the configuration. System Center support. So System Center 2012 SP1 has support for Hyper-V over SMB. It will manage all the permissions. When you create the share, it will know what machine is going to run with that share, going to set the permission right, going to help you provision that. Okay? CTP2 just came out. Use the latest one. Okay? Remote management. That's a common question. Have many different ways to do remote management. You can use PowerShell. You can use Server Manager, which now has all these ability to have a list of servers, and you can manage your shares across different machines. You can use Remote Desktop. You can use VMM. But if you're using Hyper-V Manager remotely, right? So if you have a core install and you're running Hyper-V Manager on another machine, you have to use delegation, okay? If you manage IIS in any way, you probably are familiar with the concept of delegation. The reason for that is a security requirement. When you have a box talking to another box, setting up something for a third box, you're elevating your privileges, right? You don't want a bad guy to get in your network and then start talking to all the other machines and escalating their privileges across the network. So what we do, we allow this guy to talk to this guy. If you want to use the credentials to talk to yet another guy, you have to make sure that guy can do it. It's a way to do it in Active Directory. Jose, can I do all this without doing delegation? Yes, use Hyper-V with PowerShell. And PowerShell has a way for you to remote into a box and do everything. So if you needed one more reason to use PowerShell, here it is. Okay? How do you do delegation? There are plenty of explanation how to do it. We have blog posts about this. Let's show a little bit. One thing we're doing, I'm not sure, who has heard here about cluster in a box? Good, but not enough. You need to go take a look at the setup that we have over there at the Windows Server. We have several of these things. One of the common requests we got in the past is, clusters are great, but I can never figure out all the details, setup, the storage that you need to make shared, and the SAS cabling, and all the devices that go into making a cluster. So guess what? We're working with OEMs to give you a single piece of metal that has two nodes and storage all in a single enclosure. And the idea is that you get those pre-installed with Windows Server 2012. You just join your domain, and you're up and running real fast. Okay? We have a few vendors already working on this. I actually have a blog post that came out just this week talking about different vendors that are showing it here for you to use. My demo is actually using one of them, made by Quanta. The configuration here with an LSI RAID controller that uses cluster RAID, which is new in this release as well. I'm using a RDMA NICs which support is new in this release as well. So if you want later, we can go look at the gear. I'm connecting here to the gear that's in the Tech Expo here. All right. Mandatory architectural diagram so that you understand how this whole thing flows. I'll let you look at that later. Different configurations, right? Actually, let me show you a little bit here. In this setup that we have here, we have a cluster. So my cluster is comprised of 2 file servers. And if you look at the cluster configuration there, we have MST FS1, MST FS2. I have a few disks. Now we have integration to do different types of file server. I wanted to show one thing that some people ask me, how do you do a scale-out file server, right? So when you create now in cluster a file server, there is now a couple of options. So you can do the classic file server, or you can do the new scale-out file server. For Hyper-V, we typically want you to use scale-out. Okay, there's no good reason not to do scale-out for that. You get additional benefits. And if you have more than 2 nodes, it's almost like a waste if you don't use scale-out. Okay? I already have one configured. The reason I'm doing the classic file server here is that I'm doing a transparent failover demo. And when we're using scale-out, the failover is so fast that it's not easy to show. So I'm using the slower one so you can at least see a little bump in the performance. Okay? I'm not kidding. All right. So this is the configuration of the file server. It should be fairly straightforward. You have a few disks here that I'm using. I have, for my file server, I have a few shares that you can see here, right? It should look fairly familiar to you. If you want, you can also look at this from Server Manager, right? So you can look at shares. Take this guy out. So you can see here they have my shares available. You can see the volumes, all that. This is in Server Manager. Let me switch over to the Hyper-V box. So I have a VM running here. How can you tell that this VM is using Hyper-V over SMB? It's very simple. You select the VM, you do settings. And when you look at the settings, you see that your path is actually a UNC path. That's it. That's really the difference, right? That's all it takes. In this case, I'm using several different VHDs, just as an example. So I have like an OS VHD, and then I have a whole bunch of data VHDs. So if you notice, I'm using VHDX, which is the new format. No problem there. All right. So what I'm doing here also, I have a VM running, so I'm going to start a little workload. This is a SQL.io simulation, right? And what I wanted to show here is I have from the host, I have a performance monitor. So you can see here the new performance counters that we introduced in this release. So you can see, for instance, in this case, that we're doing 512K IOs. We have about 1.2 gigabytes a second throughput there, right? And what I wanted to do is run a little PowerShell that allows us to look at our configuration. So first of all, I'm going to show you here the NICs that I'm using. So I have 2 10 gig NICs, 2 54 gig NICs, and a 1 gig NIC. So right now, if you look at it, we have a bottleneck on storage. Definitely not network in this setup. You can see your connections. So now we have the ability to, by simply using get connection, you can see all the connections to the different shares that you have, what credentials you're using, and very important, the dialect. So that's how you can tell now that you're using SMB 3.0, Just do a get SMB connection, and it will tell you. Okay? In this case, I'm using get SMB multi-channel connection to get the information about which paths I'm using. So SMB in this case, so I have 254 gig, 210 gig, and a 1 gig. So what am I going to use? I'm going to use the 254 gig NICs, and they're RDMA capable as well. Okay? I really don't need the 2 in this setup. I could live with just 1. This is more for fault tolerance than for aggregated throughput. If I were using the 2 10 gigs, I would actually need more than 1 10 gig to achieve this performance, right? Because it's slightly above the limit of a 10 gig NIC. Okay? Let me go further. So now I'm looking at the shares. That is an interesting command because I'm running this command from the client. So that is how you do remoting with PowerShell. So you do get SMB share, and you can specify a list of servers that you want to run this on. And then what it does, it goes to those servers, gather the information, returns to you. So if you want to manage a file server remotely, you can use this kind of syntax. In this case, I'm using the get SMB share. I could do a new SMB share. I could do a remove SMB share. I can do a get session. I think that's my next command there. So that's how easy it is to remote into another box. So this, for instance, is the list of sessions on those file servers, right? And now I'm doing a move. So if you're familiar with cluster, what I'm doing here is while my workload was running on the VM, I said, hey, move to the other node. Okay? So the VM is running. You can see that the VM never stopped, but I moved from one node to the other node. In this prototype system, it just so happens that IOs from one node are faster than from the other node. So I just jumped from 1 point something to, let me see what's my performance here. Oh, I'm doing 2.4 gigabytes a second. That's actually more than 2 10 gig NICs can do, right? But I don't have a problem here because I have 2 54 gig NICs, and I'm doing RDMA. Not sure if you noticed, but look at the CPU utilization in this box. It's not doing much, right? Why is that? That's because I'm doing RDMA. If you do this with regular 10 gig NICs going down and up the TCP/IP stack, you're going to see a lot more CPU utilization. Okay? You know what this looks a lot like? When you're using fiber channel. So when you're using fiber channel, you can achieve very high throughput with very low CPU utilization. Why is that? Because the fiber channel HBA, that's all the heavy lifting. So this is equivalent to that. Okay? The only difference is I'm not familiar with any fiber channel interfaces running at 54 gigabits per second. That's a detail. All right. So what you're doing here essentially is you could, and this is all, my file server is actually 2U enclosure that inside of it has a whole bunch of disks. There's one thing I'm doing here that is half cheating, is this is an all SSD setup, right? So I'm using this with 10 SSDs, this 2.5 gigabytes per second performance, right? But I have seen the folks, for instance, from other vendors showing a larger number of disks to aggregate for more throughput, okay? If you come to my SMB multi-channel demo, I'm going to show a little bit more on this system. I'm going to disable a NIC in the middle of it, all kinds of fun stuff. How do you like that? So that is SMB 3.0 with Hyper-V. You had a question? Cool. All right. So different ways to do this. Okay. Not everyone is going to use the same setup. In fact, I've had people come to me and say, Jose, can I do a very simple thing? Can I get one machine being a standalone file server and then use that to cluster Hyper-V? Absolutely, you can. Very simple way to do it. And I've seen lots of folks that just want to do a lab setup where they want to play with Hyper-V clustering. In the past, they had to set up iSCSI. They have to use, configure LUNs and configure IQNs and do all kinds of things. I have nothing against iSCSI. We actually ship an iSCSI target inbox if you want to play with that. But I just think the SMB is simpler to configure than that, and you can just simply create a share, and then you start playing, and fully support it as a way to cluster your virtual machines. Okay? Now, if you want to have something that is continuously available, I would step up from a standalone machine and use a cluster. So if you have a cluster, we have this marketing term that we use for this called active on. That means that you can transparent failover between the two boxes, and you can do all the stuff we talked about in terms of CA, continuous availability. We have a setup that we can use just shared SAS, which is an interesting proposition. You don't need to have anything other than a bunch of SAS disks in a JBOD connected through SAS. There's two easy ways to do that. One is using the new capability in Windows called storage spaces. Have you heard of storage spaces? That's one of those things you need to go back and take a look. Very important. Okay, there's a lot of those. I had a talk yesterday about private cloud storage where I did a demo of storage spaces on the other cluster in the box in this setup. And that one can also be used. In this case, my demo was using a new kind of PCI RAID controller from LSI. They call it HA-DAS. It's a new type of mega RAID controller that essentially you can use on two nodes, and they coordinate between the two, which is kind of interesting. You can use those as well. The other thing you can do is you can use SAN storage in the back. And then folks come to me, hey, Jose, that's not right. If you have a SAN, why would you use a file server? Just connect the Hyper-V boxes to the SAN. You can absolutely do that. However, in many situations, you have a high-end SAN, but you can't connect all the nodes to the SAN through fiber channel, or maybe it will cost too much money. If you have 100 Hyper-V hosts, okay, and you want to wire that to a SAN, how many HBAs do you need? If you're doing it right, you probably should have 200 fiber channel HBAs. What kind of switch do you need? 200 and something, because you have to connect the SAN as well, port fiber channel director. Those are not cheap. And for every Hyper-V node, you also need to do what? This is not just connected to fiber channel. You have to connect also to Ethernet. If you're doing things right, you probably already have a 10 gig NIC, or maybe you have a few 1 gig NICs. So what we can do is we can get, say, 5 or 4, 8 file servers put in front of that SAN. Let's use this configuration, 4 file servers. How many fiber channel HBAs do I need to connect 4 file servers to the SAN? 8. How many ports do I need on the switch? Less than 16, right? That's an entirely different configuration. Then you use the Ethernet connectivity you already have from the Hyper-V host, and you connect to those file servers. You can do a scale-out file server, right? So that's an idea. And all of a sudden, you can reduce your cost. And if you have already invested in a 10 gigabit networking infrastructure, you probably are doing it right with 2 10 gig NICs, or maybe a team of 2 10 gig NICs. We can leverage that. If you have RDMA networking, you can go quite fast. I invite you to come to the next session to look at that. Speaking of networking, here are a few different configurations. Some folks will do 1 gig networking. With multi-channel, you can now aggregate multiple 1 gig NICs. So you could potentially, for instance, we're working with one customer that's doing 8 1 gig NICs. And then they use 4 to access the storage and 4 in a team to go out and provide service. That's 8 gig. And why are they using 1 gig? Well, it just so happens that 1 gig switches are a little less expensive, and they're playing it that way. Other folks have 10 gig just for the storage network, and they create a separate network just for the cluster, the live migration, the storage, and then they have 1 gig networking going to the outside for the clients that are accessing the VMs. Fair way to do it as well. And then all the way to the end here on D, we have ideal converged network infrastructure. Everything goes to a set of 2 switches, and, you know, there's peace on earth and all that good stuff. You can certainly do that as well. Okay? Now, I wanted to use the last 15 minutes of the talk to kind of walk you over through a crescendo of configurations, starting with a very, very simple, non-highly available, non-continuously available, non-reliable setup, all the way to a more complete setup. So we start with all standalone configurations. Why would you do this? Maybe you're just playing with it. Maybe it's a test setup. Some folks over there doing training. Fair way to do it. If things break, oh, we're sorry. We'll have to fix it, and we'll maybe have to rebuild. Fair game, then you're good. A few disks could be 4 SATA disks, no RAID controller, no nothing. Just configure those. Those could be USB disks for all you know. Create a file share, have a few Hyper-V hosts coming in, fair configuration. Be sure you understand what you're getting out of this. If anything here breaks, you're down. Okay? So maybe you want to invest a little bit and upgrade to Windows Server 2012. Or maybe you just don't want to invest anything. You just get one of those new configurations with Hyper-V, the Hyper-V server configuration that Jeff Wilson was talking about in the talk, and you start doing spaces of that. Now, I want to take it one level further and have a file server, simple file server, just running, whoop, almost fell there, running the storage spaces configuration. What you do here is 4 disks, put them in a pool. Out of that pool, you create a few spaces, and you create a mirrored space or a parity space. Okay? With that, what can you tolerate? The failure of a single individual disk. Okay? But if the file server fails, you're down. If the Hyper-V host fails, you lost that workload. One level up, cluster the Hyper-V boxes. Jose, I don't think that makes any sense because the file server is not clustered. Well, you do get something out of this. You cluster the Hyper-V boxes, so if one Hyper-V node dies, cluster will automatically get the VMs running on the surviving node accessing the same file server. Of course, if you lose the file server, you're doomed. Okay? But at least you can survive the failure of one of the Hyper-V nodes. That's one way to do it. Okay? Now, you probably know what I'm going to do next. I'm going to cluster the file server. Probably the easiest way to go about doing this is get some shared SAS disks. So get a JBOD with SAS storage. It has to be SAS. It can't be SATA because you can't share SATA, right? If you understand how those buses work. But if you have a few shared SAS disks, you can use storage spaces in a cluster configuration. In that case, you're not using parity. You must use mirror spaces. Okay? Parity is not supported in a cluster. So you're going to actually cluster the file server. And in that case, I would highly recommend the scale-out file server so that you can see all the spaces from all nodes. And both servers can provide service to your Hyper-V hosts. Now, obviously, here I reverted the Hyper-V hosts not to be in a cluster, just to show that you could do that as well. But you know what's the next logical step, right? We're going to cluster the Hyper-V and the file server. In that case, you have the file server cluster at the bottom, continuously available, and you have the Hyper-V host also continuously available. Commonly at this point, I get the question, Jose, why do I not use a single cluster? You could. That's a fair way to do it. However, many folks try to use a file server that serves as storage for a whole lot of things. And you could actually have, if you notice in the performance that I was showing here, you can have a file server cluster that serves multiple Hyper-V clusters. You can scale them separately. You can put more storage in the file server cluster that's going to benefit all the Hyper-V nodes, right? If you have that configuration, you can have hundreds of Hyper-V hosts connected to a few file servers. Well, we can only put 64 Hyper-V nodes in a cluster, so maybe you want to do 2 clusters of 64 and connect that to a single file server cluster. Okay? So all those combinations are possible. By all means, you can also have just the Hyper-V cluster. You knew about that one. Now, my very last step is a complaint that I commonly get: clusters are too hard. How do I make those happen? So, buy a cluster in a box. The cluster in a box comes with all the pieces that you need. It comes pre-configured with all the required storage, all the required networking, and the work we're doing with vendors is to actually get to you a machine that's pretty much ready to go. The only thing they can't do there is to join your domain. So you're likely just going to configure networking, join the domain, and you're up and running. Okay? Most of the work to do, like the storage spaces configuration, or if it's another kind of cluster in a box that uses HADAS or cluster RAID, or if it's a cluster in a box that uses fiber channel storage, you could do that too, or SAS storage arrays. All these things can be pre-configured for you. Now, on the Hyper-V side, the way we're making clusters easier there is that pretty much all you need on those hosts is networking. The storage is entirely coming from the network. Okay? So it's very straightforward to form a cluster there. Okay? So, in summary, you have different ways to do this. You can have different types of networking, different types of server, different types of storage. But the message I wanted to deliver to you is that, first of all, I've seen folks saying, oh, you can do file as well. I wouldn't say it that way. I would say that starting now, Hyper-V has shared storage with iSCSI, shared storage with Fiber Channel, shared storage with SMB 3.0, and SMB 3.0 is first class in that set. So it's not a second class of storage. You can yes? Well, I'm a PM in the file server team, so what do you guess? I prefer the file server type. No, I'm kidding. There are different ways to do it. If you have investment in one technology, you probably want to continue to use it, right? There are certain things that you can't do from SMB. For instance, you can't boot a diskless blade from SMB. So for that, typically, folks will use iSCSI, right? But once you boot the blade, there's no reason not to go do SMB after that. I think SMB is very flexible. Lots of folks are doing Fiber Channel as well. The shared SAS solutions, for instance, are only supported up to a few hundred spindles. So if you want to have a solution with a few thousand spindles, you're most likely doing a Fiber Channel SAN or iSCSI SAN, right? But in that case, you have much more flexibility. What I'm trying to say is just that don't dismiss SMB 3.0 and say, oh, it's a smaller, less performing solution. No, in fact, I've seen folks that are doing high-end Fiber Channel SANs that like the idea of front-ending it with an SMB 3.0 solution. Okay, so that's not a second-class solution at all. And you have lots of flexibility. What is the right solution for you? It will vary. We just want to make sure that you had a good file solution if you wanted to go there, okay? A few sessions were delivered in TechEd North America, and the recordings are available. If you're interested in doing SQL over SMB, okay, we have full support for that, and we had an interesting demo with a cluster in a box of an entire different type. It was an all-flash violin memory box in a cluster in a box configuration that had a very interesting performance. I would highly recommend that you go take a look at that. We also had a session on the continuous availability under the hood by Klaus, who's a PM that works with me. We're both principal PMs in the file server team. About half of the features he worked on, the other half I worked on. I highly recommend that. It's a 400-level session, so be understanding what kind of trouble you're getting into. But he goes into a lot of detail and what the witness service looks like, what actually happens when you fail over from one node to the next, there's actually quite a lot of magic going on there, and he explains a lot of how it works and shows a scale-out failover, which is pretty much a non-event. I showed the classic one, so you could see the little bump going down, then up. It was a few seconds, right? And in the scale-out, you don't see anything. It's just, it's going there, and it continues going, and you have to go look at the event log to see that something happened. That's pretty much how it goes. Okay. We also have other sessions here. So we have, of course, the one you just saw. We have a cluster in a box session right after here. I recommend you go take a look there. We're going to play a little bit of hardware geek. We're going to pull apart a cluster in a box, see what's inside, and look at some different setups. We're going to talk about RDMA as well. I'm going to show a demo with higher performance than just 2.5 gigabytes a second. Okay. I'm going to do a slightly bigger number. We're going to talk tomorrow about NIC teaming. And there's also a talk about standard support and interoperability. We're going to talk about our effort to establish SMB 3.0 as a way that many different vendors can offer file storage, not just on the Microsoft platform per se. And I would highly encourage you to also, forgot to mention, I got this new vanity URL. If you want to get to my blog, you can now just say smb3.info. That's the URL for my blog now, okay? So just do smb3.info, and you're going to go here. So you see a few of the things. For instance, we had a recent blog post talking about all the types of cluster in a box configuration we have, so details about the Quanta box that I use in this demo, and a screenshot of the demo you just saw, right? It's kind of a weird thing. You just saw you saw the demo, already posted the blog, right? No, come on. The other cluster in a box solution with spaces, so there's the spaces configuration, have the HP one, have the violin memory one, showing 4.5 gigabytes a second, and 200,000 IOPS with SQL. We have a setup that I'm going to show in another session in a moment, so I'm not going to show it there. You can look at it later, okay? So that's about it. The other thing I wanted to ask is please fill up your evaluations. That's very important for us. That's how folks understand how we're doing. If you like the session, if you like the demo, please go there and send an evaluation. And if you have any questions, I can take them right now. Questions? Go for it. I'm going to go down. I almost fell once. I don't want to risk it again. Yes. So the question is, we're doing scale-out testing, and we put the file server on a VM, right? And should I use a physical solution or a virtual solution? Well, there's a chicken and an egg problem there. You can't virtualize virtualization, right? And if you're planning to use your file server to support Hyper-V, you better not be doing the Hyper-V in the same one, although we've done that. If you do it separate, the main thing you're going to see is make sure you have storage that performs. Because there are two types of clusters that you can use in a virtual environment. You can use, actually three. You can use iSCSI, you can use Fiber Channel, or you can use SMB. So if you have a SQL guest cluster, you can do a SQL guest cluster with SMB. But you can't do a guest cluster with SMB for a file server, because that doesn't make sense, right? So it's iSCSI or Fiber Channel, and you just have to know what kind of performance you're getting into. You're definitely not going to get this level of performance if you're doing in a VM. It's a fair game for learning. I even once had a single box as a demo. So I had Hyper-V. I created a VM that was a file server, and then I created another VM using the file server that was in the other VM on the same Hyper-V host. Don't try this. It's not a good idea. Okay. Yes? Yes. No, it's not considered a loopback if you have a VM in another Hyper-V host. Yeah, but I wouldn't recommend to do this in the same machine, right? For demo purpose, you might want to go there, but it's definitely kind of tricky. I've played with it. We actually had a hands-on lab that was just that at one time. Yes? LBFO and RDMA. Yeah, so we call that NIC teaming now, and RDMA. So I have a session on that tomorrow. I'll invite you to come over, but I can give you the short answer. When you team two RDMA NICs, the team is not RDMA capable. The problem is when you're doing RDMA, I actually do things directly to the NIC, so I have to do like a memory registration with the NIC. When you team that, you abstract. This is no longer the physical NIC, it's a virtual NIC, and that virtual NIC, I cannot do the same RDMA programming on it. So it doesn't work. The multi-channel and teaming without RDMA is a fair game. We actually detect teaming and behave differently on a team. So that's absolutely fine. And if you're interested in multi-channel, session tomorrow has lots of details. It's actually a combined session on both teaming and multi-channel on the same session. Other questions? Can you use an IPv6? In general, we support IPv6 through and through. There are some details on how you decorate IPv6 addresses that some people sometimes miss, but there's no problem. Just be careful with multi-channel. Some folks have a little bit of, so if you have two paths, right? If you have a 10 dot network and a 192 dot network, but they're both 1 gig between two hosts, and you do a / 10 dot something, SMB multi-channel will actually detect the other NIC and use both paths. So just because you specify an IP address, don't imagine that it's going to use just that one. We're now actually discovering topology and using more than what you specified. But we fully support IPv6 across the board. Okay? I'm not sure I'm going to hear all the way in the back, but try it. Okay, so the question is, I showed the permission setting through PowerShell. Can you do that on a wizard? Yes, you can. There is, in Server Manager, a new wizard specifically for that, and it actually does some checking. So, for instance, if you grant permission to one cluster node, but you forget to do it for the other cluster node, it will actually prompt a warning and say, hey, it looks like you're doing this for a cluster. If you're doing this for a cluster, we highly suggest that you use all nodes in the cluster. So there is a wizard. It will help you with those permissions, and it has some extra checks. It's just that for any kind of private cloud deployment, something more sophisticated, we highly recommend that you learn PowerShell. But if you want to use Server Manager, fair game. There's a wizard for that as well. Yes? It is possible to use DFS with Hyper-V over SMB, as long as you use DFS to point to the right location. DFS is actually a referral service. So when you use a DFS path, we talk to DFS to get the actual address, and then SMB goes directly to that address. So it's fair game to do that as long as you know what you're doing, right? And I still highly recommend that the target of your DFS share be a continuously available file share. And if you're doing DFS and DFS is not highly available, then there is a single point of failure. So I highly recommend that you use domain DFS and you have multiple DFS servers on your network, so you have full tolerance at the DFS level as well. By the way, domain controllers, multiple. DNS, multiple. Everything, you should be seeing everything doubled, right? If you want to have high availability. Mm-hmm. Mm-hmm.
That's a great question, and I'm glad you asked. So there is a new capability in Cluster that you can create aliases for cluster names, and we will now accept IP addresses and aliases. Look that up. There's a new capability. Is it the property of the cluster? The IP addresses, thanks to the cluster team, they did that for us. And there's a way to work around that. We have an issue that if you use an alternate name, it wouldn't work with cluster, right? Just be careful about Kerber's authentication in that scenario. Okay? All right. Thank you, everyone. We're over our time, but go play with SMB.